Let's now have a look at a complete program that does a simple animation. Let's have a look at the animation first to see what it is meant to do. Now let's have a closer look at the code that generated this animation. We have three parts to this program, which are each executed in a slightly different way. Any code that is outside of the setup and draw functions is executed first. In this case, we are creating a single integer variable called y, which will represent the y-coordinate for our rectangle. As you can guess, this value needs to change every time we redraw our rectangle. Each program can only have one setup function and one draw function. The setup function is called once only and is the second section of code that is executed. Recall that the code contained within the setup function is used to create our background canvas as we want it to be at the start of our animation. In this case, we create a 200 pixel by 200 pixel canvas, set the background to a dark red and the fill and stroke color to white. After that, the draw function is called repeatedly until the program is told to stop. Our draw function draws a rectangle each time it is called. It uses the value of our y variable to tell it the y-coordinate used to position the rectangle. The value of our y variable is also updated each time the draw function is called. We add 1 to the y-coordinate value each time the draw function is called, which slowly moves the rectangle down our canvas. Let's try it and see. Why do we set the background again each time the draw function is called? Let's try executing our code without that line of code and see what happens. Why did this happen? Let's go back to our draw function and see whether we can figure it out. What happens each time the draw function is called? The code is executed each time, which in this case draws a white rectangle. Each time the draw function is executed, a new rectangle is drawn, 1 pixel further down. If we don't clear our canvas in between, we will see each rectangle that is ever drawn. Setting the background color will reset the canvas as we want it. Of course, you may want to see each shape that you draw. That's up to you. If you do, you just need to remember to not reset the background color. We can improve our program even further. At the moment, once the rectangle has moved past the bottom of our canvas, it is no longer visible. We could change our program so that as it starts to move past the bottom edge of our canvas, we reset the y-coordinate so that it starts from the top again. How can we do this? What we probably want to happen is for the rectangle to start moving past the edge of the canvas. We can see that as we draw the shape, if the shape extends past the edge of our canvas, we only see part of the shape. We can take advantage of this. Once the y-coordinate for the shape is large enough that the shape is over halfway off the edge, let's reset the y-coordinate so that it appears back at the top. Let's have a go. We would need to add an if statement that checks whether our y-coordinate is greater than 200, and if so, sets it back to the start of our canvas, or 0. This is a little jarring though, as while the rectangle slowly moves off the screen, it appears back at the top all at once. How could we fix this? What we can do is start to draw our shape slightly higher than our canvas, so that it appears again in part. We can do this by setting the y-coordinate to be a negative number, which means that the shape will start to be drawn above the top edge of our canvas. Let's try this out with a single shape. We can also set negative coordinate values for the x-coordinate. Let's go back to our program to see how it worked. Okay, now we have seen an example of how we can use continuous drawing in our processing code to create animations. There is one last thing that I wanted to talk to you about in this lesson. By default, frames are drawn at a speed of 60 frames per second. But we can change that by simply changing the value of the frame rate using the frame rate function. If we want our programs to run a little more slowly, we might set our frame rate to 30, like so in our setup function. What happens if we run our code now? You will notice that it is easier to observe what is happening in our program, although the animation is not perceived to be as smooth. You might want to reduce your frame rate when testing your code, as it is easier to see what is happening.